Hello, and welcome to this video on the Bullwhip Effect. This is a part of Operations Analysis course at IIT Bombay. First let us look at a small scenario. John's friends and family are staying with him for a few months, and buys more coffee than usual. The local supermarket sees the increase in demand for coffee and increases its order size with the warehouse, to refill buffer stock. Then the warehouse sees the increase in order from the supermarket and places a larger than usual order with the manufacturer. John wanted 10 units of coffee instead of 5 just for 1 month. The supermarket saw this as an increase in demand and orders 15 extra units, which includes safety stock. The wholesaler, to cater for the increased order, orders 20 extra units in bulk from the manufacturer. The manufacturer, to bring down the cost, manufactures 40 extra units. The demand was only for 10 units and the manufacturer produced 40 units. The result: factory overproduces coffee, warehouse stockpiles extra coffee, supermarket holds extra coffee and delays next order. Small changes in demand at customer level can produce large demands in upstream stages in the supply chain. This is called bullwhip effect. The amplitude of the wave of demand increases and moving forward, which looks like a whip as you can see in the figure, hence this phenomenon is called bullwhip effect. The concept first appeared in J. Forrester's Industrial Dynamics, and thus it is also known as the Forrester effect. In more formal words, the observed propensity for material orders to be more variable than demand signals, and for this variability to increase the further upstream a company is in a supply chain. So, let's see what caused this effect in our example. The major reason was demand forecast updating. Each member updates its own demand forecast based on the orders collected from its downstream customer. The more members in the chain, the less these forecast updates reflect actual demand from end customers. Like in our example, the supermarket ordered 15 extra units, the warehouse seller ordered 20 extra units, and the factory manufactured 40 extra units of coffee. This was a complete disaster as the customer only wanted 10 units but the factory produced 40. This shows that a small change in demand at the customer level amplifies 4 times till it reaches the level of the factory. We can see that this increase in demand, as it goes along the various levels, resembles a bullwhip, which gives it its name. The second major cause that causes the bullwhip effect is rationing and gaming. If the buyer knows that the retailer is delivering only a fraction of the order placed, he attempts to game the system by making an upward adjustment to the order quantity. So basically, the supermarket owner feels that whatever quantity he orders, the wholesaler will give him a little less than that, so he orders more than he needs. The same thing is done by the wholesaler, who orders more than he needs from the factory. If there are a lot more levels, this effect is amplified way too much, and this leads to the factory producing way more than what the customer actually wanted. As a result of inflationary factors, quantity discounts or sales tend to stimulate customers to buy larger quantities than they require. This behavior appears to add variability to quantities ordered and uncertainty to forecast. This can be seen in festivals like Diwali, which brings a ton of sales. Prices go down drastically. This obviously increases demand at the customer level, and it is very difficult to forecast this sudden spike. For example, this year, the sales jumped to as high as 72,000 crore, which was quite unexpected. This increase amplifies as we go up the supply chain and cause the bullwhip effect. Hence, such fluctuations in price also contribute to the variability of demands at different stages of the supply chain. Order batching takes place when each member collects order quantities from their downstream customer and rounds up or down to meet production constraints such as equipment setup times or truckload quantities. For example, let's say the demand at the warehouse level is 1,300 units, but the factory can only produce the quantities in multiples of 1,000. In this scenario, the factory would have to produce 2,000 units, causing an extra stock of 700 units. The more members of the supply chain who conduct such rounding of order quantities, the more likely a distortion occurs of the original quantities that were demanded. Now let's see how to tame this bull, that is, how to prevent the bullwhip effect. We saw 4 causes for the occurrence of the bullwhip effect. Now we will see how we can mitigate them. To avoid multiple demand forecast updates, the companies should make the demand data from one stage of the supply chain available to other stages. In particular, demand data from downstream should be made available upstream. Another option is to sell the customer directly by bypassing the downstream stages. Also, companies should improve operational efficiency to reduce highly variable demand and long resupply lead times. Another reason was rationing and gaming. In the situations of shortages, the suppliers should not rely on the orders of customers because they might exaggerate their orders for stockpiling. The suppliers should refer to past sales records and make rational decisions. They can also eliminate their generous return policies, so retailers are less likely to cancel orders. The third reason we saw was the fluctuations in prices. The manufacturers can regulate the price discounting in order to prevent customers from buying in bulk and stockpiling. They can also deploy activity-based costing systems that regulate the prices by taking into account the number of stocks bought by companies or customers. To prevent the bullwhip effect arising from order batching, companies can use electronic data interchange to reduce the cost of placing orders and place orders more frequently. The companies can also ship assortments of products in a truckload to counter high transportation costs or use third-party logistics companies to handle shipping. With the situation of COVID-19, there is a huge demand of items like tissue papers and sanitizers. This has led to pharmaceuticals and grocery stores stocking huge amount of these items. Since such large usability of these items is limited only to this period, it is highly likely that these industries might see bullwhip effect in post-COVID situation. To some level we can see this happening currently also if we compare the situation of sanitizer availability during the onset of corona and currently, where earlier there was a shortage of these items while now they are available in abundance. Beer Game is the game version to experience this supply chain problem of bullwhip effect. Since information about the actual demand is visible only to the retailer, the others in the line try to follow the demand of its previous entity in the supply chain. Though the actual demand becomes constant after a certain point, if any entity in between attempts to continuously stock for some anticipated demand in future, then it can have major consequences for the whole supply chain. And we observed this phenomenon when we played this game in our class where some teams were highly affected by this effect while some were not. Thank you for watching. If you liked this video, don't forget to like, share and subscribe.